Great. Thanks for this opportunity. I was listening to some of the talks this afternoon, and it's nice to be part of this meeting, even if remotely. What I'm going to show you is something what we call BHTOM, Black Hole Target Observation Manager. Black hole because it's a nice name and it catches people's attention. And this is a network this is a global network of telescopes. And I dare to call it a research infrastructure for time domain astronomy. So the main purpose of this network is essentially to continue what we've just heard in previous talks. What do you do with all these candidates for supernovae? If you filter in Think, you find zillions of transients of your particular type. Then what do you do with them? If you find in Treasure Map, if you find 10 or 20 candidates, counterparts to gravitational waves, what do you do with them? So this is where we come in. We are not a broker, we're feeding from brokers. What we are, so as I said, so Black Hole Target and Observation Manager is a web page which is built based on a TOM toolkit from Las Cumbres Observatory. So we've expanded it with some additional features to work on a heterogeneous network of telescopes. Essentially, it's a web tool for coordination of time domain observations. It handles automated observation requests. It does processing of raw images from about 100 of telescopes now. It does standardization. It reads the archives. And it's open to new users, new telescopes, new target. Any type of target of time domain value can be added here. Not only transients, also we can observe boring variable stars if they are of interest, if someone has such interests. Okay, so just to show you a schema how it works, to explain in more detail, all we've heard about so far is that there are surveys, and I come from surveys like OGLE or Gaia, among many others, and then there's going to be LSST soon. There will be floods, there are already floods of alerts. They go to brokers, and I just showed here a couple of examples. We heard about them, and these go to users, and then the users, they can have their ideas, what to do with the data. There are 10 candidates for GW optical counterparts. Or there is someone saying, I want this particular object to be observed for 1 year, just keep observing it. So these requests, they go to our webpage, bhtom.space, and we take care of all the communication with the network of telescopes, right? So you see, we separate the users from the telescopes, which has benefits for many people, as you can imagine. And then we take care of all the data flow, not only sending the requests to telescopes, but also we take the data from these telescopes and we process them. At the same time, we grab the data from vast archives, public archives, which are now growing in numbers and are longer and longer in time as well. And then we deliver science-ready data products, mostly photometry. This is focusing so far on photometry, but we're also thinking about expanding to spectroscopy, polarimetry, astrometry, and so on. And then this goes back to users, and users, they can do whatever they want with it, right? They can write papers, or they can rule out some of the candidates they wanted to observe. Of course, these days, everything has to be done by bots, and our system is bot-friendly, so you can just replace the humans here by the bots, and everything here can be done automatically with us sitting and just watching our papers being written by the AI. So the telescope network, it was actually established already back in 2013, was built mostly for Gaia science alerts. So Gaia, the space mission, was delivering, is still actually, it's in its last year, is delivering alerts from the whole sky, and we needed the follow-up for them. So far, this network has grown to about 100 telescopes, mostly around Europe, as you can tell, but also we cover the entire world. The sizes come from 0.25 to 2.5 meters, so the whole range of apertures. So that includes professional telescopes, amateur. We have schools collaborating with us, outreach facilities which are equipped with very good instruments these days. So many of these telescopes are manually operated. Some of them are robotically operated. Some of them have good weather. You see here in the color coding is the total cloud cover in percent. So you see some of them come from poor weather regions, but still they have these couple of clear nights they can contribute to the observations. And many of these telescopes, they just volunteer in the network. They donate the amount of time they can afford doing their own projects. Some of these telescopes, we apply for time and we get the time and we give it to other people to use. As I said, we cover multiple science cases, and I show here some examples. We don't restrict to one particular science case, so we can use this system to study cataclysmic variables. You see you see 20 years of data here for a crazy cataclysmic variable. We do microlensing events. We do quasars, AGNs. All sorts of things can be done with everything time domain, everything changing in time on short or long timescales can be added to the system. I will just stop here a little bit more. I say a little bit more about the image processing, because this is a unique feature we built into our system. Essentially, the system is capable of automated data processing. We do the PSF photometry from the entire array of telescopes. If you have a telescope, you can just contact us and we'll make sure your data will get processed. You'll never have to do the photometry yourself. We do it in a homogeneous way, and then we do the standardization. We calibrate everything to Gaia synthetic photometry. We also do the automated detection of filters, so we can handle non-standard filters as well. You see here some examples of some targets observed by various telescopes. And then the data, once it's processed, standardized, it's downloadable, and it's science ready for everyone who's registered. And here are some more light curves of a supernova collected by this network and a planetary microlensing event. You see these data points, they're all collected by various telescopes, but essentially you can't see the difference which data point comes from which telescope, because we try to calibrate these heterogeneous instruments very much. However, on the other hand, we keep track who had collected each data point. So we keep track of the contributions of everyone, just to give people enough credit for their work. One word about the archives. So there is an automated harvesting of time domain data for any target with known coordinates. We use public data, things like ZTF, of course, but also we go to infrared, even radio. If some targets have radio counterparts, we grab things like CRTS or linear, SDSS, Gaia, everything what's available at the moment. We expand this with new data releases as well. So essentially, by inserting a target into our system, just immediately you get the entire light curve of everything what is known about the target. You can immediately start analyzing your object after this being added to the system. There's a couple of papers already we published, or people working with our data published, covering multiple science cases from microlensing, supernovae, young stellar objects, and so on. But the thing is that we include all observers. We give credit. We keep track, first of all, of who observed what, and then we include every single observer into the paper. This is probably more and more common practice, but that's to encourage people to voluntarily donate their observing time to our system. Of course, everything these days has to have an API, as we heard before. So all functionalities of BHTOM I showed you, you can either click them through the GUI, or you're most encouraged actually to use the API. And you can use the API to script the data flow to or from telescopes. You can submit your observing requests. You can upload imaging for processing, all done automatically. And Astro-COLIBRI is the best example of a system using this feature already. So we essentially, with one click of a button in Astro-COLIBRI, you can add the Astro-COLIBRI target to the BHTOM, where then it gets observed. And we work with Fabian, of course, and his team to improve this interchange of data. Of course, we provide scripts if you want to have bulk data downloads or uploads or target selection and stuff like this. And there is, of course, a documentation. Just coming to an end, I'll just mention how BHTOM can be used for GW. So first of all, we're a distributed telescope network, so we can respond to multiple candidates for GW counterparts. Maybe we're not best suited to find them, but once you find them, then you can submit all of them, whatever number there are, and you can submit all of them to the system, and then we'll take care of the observations. So the targets can be added, and as I said, we cover all hemispheres, and then the next step is that every target you've added can be checked if it's been doing something in the past. So you can quickly look up what was the history and what was the historic time domain data, what is showing. And of course, there is an automated data processing. So every time an observer submits an observation, takes an image, then the data is being automatically processed. So you can, in principle, you can make an automated loop. You submit a candidate, you wait for the observation, and then you either confirm it or reject it. And then the last comment I would like to mention here is that we've been working with the galactic plane for ages, for multiple science cases as well. So we are not afraid of the galactic plane, which I think many people are. As you see, these error maps of GW, they very often go through the galactic plane, which I think is still missed region of the sky, which we could also search for counterparts. There is a newsletter with this link, and I'll stop with advertising the workshops we've been doing for this network since 2010. There is a workshop actually next week in Crete, where you can actually listen to this if you want online. It's all going to be streamed. So we will be gathering the network, discussing the progress, and talking about future plans. And I will already advertise the workshop next year, which will be done within the new European project, ACME. It will be in Tenerife around September time. So I'll stop here and take any questions if you have any.